In this journey, free the Fortus, now we have access to push the buttons to print the materials that we need to print that solve the problems our clients are asking us to solve. We are a global partner for Stratasys on the OpenAM. We're early in the phase, so we're learning, Stratasys is learning, and we're doing it together.
It's exciting for us to be on the cutting edge of this program, pulling the doors off, so to speak.
This is awesome. It's like nothing we've ever done before.
Welcome back to our Free the Fortus podcast. This is the second one. We had a great podcast last week with Tom Leach from Stratasys. Learned a lot about the organization and some of the driving forces behind the OpenAM program.
Tom is full of energy, and last week when we had that call, Stratasys engineers were on site at our facility working with our team, setting up the OpenAM on our Stratasys 450 MC, and Tom was really excited. I think we were excited at what are we going to step back into, and it was successful that we've had a week running the OpenAM on the 450. We've run our first validated material with Stratasys, and we fine-tuned that. We have a process where we can produce great-looking parts with ABS, carbon fiber-filled material. And we stepped away from that first sort of test run or concept, make sure we understand the system, and we're focused on PEKK now. So we're looking at running some of our PEKK production on the 450 MC, and our team is dialing in those settings, and we've had parts come off already, and that's within a week, along with having ABS on the table, running and successful.
So they started late Monday, and today is Friday. And so just within a few days, they've gone through a series of fine-tuning runs. And the PEKK that they're running is PEKK, and that's not part of the Stratasys Validated Materials set. So our team is going full OpenAM.
Yeah, that's a material that we purchased ourselves, and we've set up the parameters ourselves. So it's not sourced through Stratasys. It's the old material that we brought to the machine.
And that's not the only thing that Sean's doing, right?
No, Sean is working on many things, so this is like a side quest for him.
Okay, well, that's remarkable to me as I think back to some of the other production projects that we've geared up for with PEKK and the time and energy that's gone into the coding and the fine-tuning. So from my standpoint, I'm really jacked up about the fact that within just a few days, they've gotten parts that look good.
Yeah, running on a sort of controlled software that Stratasys has for OpenAM gives us a thoughtful user interface to make those changes and to improve the production parameters. So, without that, we're left on the open side where we have to educate ourselves and find workarounds within the open tools.
Yeah, so in this case, it's as much about the software as it is about the hardware.
Yeah.
Those two come together to create the solution.
Yeah.
And today we're here with Nate Litmer from KIMYA. And Nate Litmer is a business development manager with KIMYA, and KIMYA is a polymer company. It's pretty interesting because they actually have a division that does additive manufacturing as a service bureau as well, but they're focused primarily on highly engineered materials.
And as you'll hear, KIMYA performs a lot of its activities like DI Labs does, or we perform activities like KIMYA does. They have a lab where they're able to process new materials, and they have to go through the validation of those materials on machines so they can support their clients with applications. And that's just a piece that we're really aligned on, and it's neat to hear some of Nate's applications and really his perspective on the industry as a whole.
Yeah, it's interesting. One of the things that we feel, and we continue to hear from companies like us that are venturing, pushing the bounds on additive manufacturing, is there is so much education to be done. And there is so much work in getting that paradigm shift to take place from traditional legacy manufacturing to thinking about and incorporating additive. And it sounded like that's something that KIMYA is really working towards as well. So it's on one hand, it's really great to hear that there are other businesses that are recognizing the shift that needs to take place and taking action to make that shift happen.
We need more problem solvers to support the supply chain challenges that we're faced with, and just finding ways to manufacture parts in the U.S. and manufacture them in-house.
That's exactly right. Well, after after this conversation today, I'm delighted to be connected with Nate and KIMYA, because I think there's a lot of opportunities for us to leverage some of their engineered materials to help our customers solve some demanding problems.
Hope you enjoy this journey that we take with Nate and KIMYA as we learn about their operations and how they manage applications with engineered materials, and how the 450MC is a key support tool in ensuring that the rapid adoption of these engineered materials is successful.
We're really excited about this episode. We've got a great guest. We've got Nate Litmer from KIMYA, and KIMYA is a critical component of the partnership with Stratasys for the new validated materials. KIMYA focuses on PEKK, which is referred to as PEKK, and it's a material that is highly engineered. It's often used for aerospace and projects that require a great deal of chemical resistance and heat resistance. You know, what they say is PEKK is the new PEEK. That's not really true, but PEKK is a highly engineered material. It's got a ton of benefits for strenuous applications. And Nate, we're really happy to have you on this episode. Nate Litmer is Business Development Manager with KIMYA. Nate's been in the manufacturing industry for virtually all of his career and has been with KIMYA for the last just under 2 years and making significant impacts with KIMYA's polymer division. So, Nate, if you wouldn't mind just sharing a little bit about yourself and KIMYA.
Sure. No, I appreciate it, guys. Thank you for your time this morning. So at KIMYA, we look at the additive space in 3 different ways: materials, lab, and KIMYA factory. Materials we've been developing from your recycled PLAs all the way to PEKK and PEI, which you had mentioned earlier. We utilize KIMYA Lab for special formulation for specific projects, applications, to provide a overall technical value that's going to increase efficiencies. And then the KIMYA factory is something that we've really worked on here lately in utilizing those high performance materials like a PEKK into the industrial space. That's the space I came from. So I was manufacturing and selling manufactured parts in the industrial space for roughly 12 years. That industry is very old school from a traditional manufacturing standpoint. So they've always done things a certain way. Utilizing additive within the industrial sector has allowed us to look at applications which in the past would have been considered extremely difficult to do. High temperatures, mechanical resistance, and the properties that it provides a lightweight part to increase the overall efficiency of the system. So that's kind of where I focused my time over the last year and a half, is looking at those industrial companies, the applications, and the potential materials that we can utilize to increase those overall efficiencies, and frankly, change the mindset that there is something else out there beyond traditional manufacturing. These additive opportunities, these additive parts can increase your efficiencies, decrease your overall costs, and optimize your system. So that's what I've been doing over the last 14 months.
Thanks so much for sharing that. You know, there's a lot to unpack with what you just said, and I'm going to try and remember all the questions I have. But I'll start with something I picked up on what you described for KIMYA, is that there may be 2 divisions. There's the polymers division, and then you also have a manufacturing division, which you're calling the factory. Can you talk a little bit about those 2 divisions and how you're helping customers and who a typical customer might be for both divisions?
Yeah, so for the materials, first and foremost, we produce the materials in our French location. we bring it over here to the Hebron, Kentucky location for distribution. We work through channel partners across the U.S. and Canada in doing that. Our service bureau here in the States is in Hebron, Kentucky. Now, like anything else, we're looking for applications where we can truly provide value. And why I say that is that tends to lead towards a technical material realm and high performance material realm. So there might be some similarities within the overall client base that we're trying to attack with those materials and this potential 3D printed parts. What about an ABS composite material or a PEKK composite material? How can we provide the overall value that the client's looking for, increase their efficiencies, and really hit the specifications that they're looking at within their overall project?
So when a client comes to you with a specific material like that, I'm assuming it's an additive material where they're wanting to 3D print it. What does the process look like for, you make the material, what do they run that material on? How do they bring that part to life?
That's a big component, right? Because there's so many open systems out there. Understanding, number one, what the application is, what system that they're running that material on, so we can make sure that we've got a profile for it and we can give that to them. Because at the end of the day, if we're trying to convert somebody over into additive, or they've got a 3D printer, but they're still kind of working their way through the process, you want to make sure that their first time doing it is a success. Their second time doing it is a success. That's what's so interesting about this Fortus 450 open platform, is it's a very reliable system. So pairing that reliable system with high quality products and somebody that knows how to print, because it's not just press and print, you're increasing the overall success rate in general. So in doing so, now you're creating that buy-in, not only from that client, but potential clients that they talk to.
Yeah, the thing that we found as you talk about that, the 450 being robust, is if you have open systems and you've created a custom material for that, a lot of open systems on the market today, the variability between each system is fairly high. So you have to manage that between printers, and being able to dial a system in like the 450 gives you the capability to scale up the production because you've got a known machine.
Absolutely.
That's probably where we're most interested and excited about this project. Is we do production, we run production on an open source machines, and we're often running engineered materials. And those machines themselves have been the bottleneck. The materials are to a certain degree as well, if they're not high quality materials. But it's really exciting to hear KIMYA's depth and breadth in polymers for the additive space, because there's a lot of applications that we've attempted to pursue in the past, and while we may have been successful, they weren't scalable. So working with the 450 and working with KIMYA, I'm pretty excited now about the opportunities that creates for us solving customers' problems moving forward. And this is the space that we really focus on. Engineered materials with really challenging projects, we find that's where we can add value. So it's great to have this conversation with you today and to learn some of these things about KIMYA.
It's interesting. When I started, a lot of my past clients had reached out and said, "Okay, what is additive? What are you guys doing?" And now, and we've seen it globally, supply chain's an issue for everybody. It doesn't matter what industry you're in. So we've looked at it and said, okay, if you've got a part that it's going to take you 8 months to get in, and your system, your production system requires this said part to run, or else you're losing, $100,000 a day in lost production. Is 3D a viable option to fill that gap and fill it with an engineered material that can be 3D printed on a reliable system? The answer is potentially yes, depending on what that application is, right? So I've run into that scenario a lot over the last 12 months. Some successful, some very much trial. And hey, we tried it, didn't work. But at the same time, as industries continue to drive forward in understanding what else is out there, i.e. 3D print, FDM, we're increasing those overall chances. We're increasing the awareness, and having highly engineered materials of high quality on a high quality system like the Fortus 450 allows us to increase the success rate and the overall success printability on those parts.
Couldn't agree with you more. You know, one of the things that you mentioned as you were providing background about yourself and KIMYA is this paradigm shift from traditional manufacturing, traditional industrial manufacturing to additive. And that's a big deal. I think that shift is underappreciated, and the challenge to get through that process is underappreciated. It's significantly harder than you think. And that's something that we also face quite a bit as we're educating customers for more advanced solutions. And then there's two things that we face in that hurdle. There's three things. One is the convincing that there's a possible solution with additive, and educating on additive. And then you've got the technical hurdles, and then you've got the economic hurdles. And not every application is going to be, and you mentioned this, not every application is going to be best served with additive, with highly engineered materials. Could you give some examples of the types of applications you've served in the last 12 months where some of your highly engineered materials have really brought the solution home?
Yeah, we've actually 3D printed some gears for a manufacturing line, and we utilized our PEKK material in doing so. Robust, mechanically strong. It actually worked better than the previous iteration that was in there. And frankly, going back into the industrial space, I had a client reach out to me, said, Nate, I've got I need a seal for one of my systems. Right now, it's about 6 months to get that part in. Is there any potential that you guys would be able to 3D print this part? We're able to 3D print it, once again, out of PEKK. It had the thermal resistance needed, the mechanical resistance needed, and they were able to put it to the kiln system. So we're talking about a cement industry, an industry that you would never really think of, 3D printing could be a viable option there. It worked, and it worked extremely well. So understanding, obviously, the environment that the application is in, the part requirement or the design requirement, and making sure that, yes, FDM is a viable option here, and we're not looking at another additive technology.
So in those two use cases, as you were gearing up to support those applications, what sort of challenges did you have utilizing current open source equipment to bring those to reality?
Honestly, the repeatability component, because there's so many open systems that we have in-house right now. But when you're talking about a high performance material, there's only certain systems that can actually play in that realm, right? So having the speed, the precision, and the overall repeatability of the part was probably the biggest issue that we had early on. Eventually, you're able to dial that in and drive it, but on the early on, that was the biggest issue.
So, as you're testing and improving the print parameters, what sort of technical team do you need to make that a reality too? Because part of it's machine and making sure it's reliable, but the other part of it is having the technical capability.
Yeah, you're right. And so that's why, to me, it's important to understand what type of backbone we have at KIMYA. Understanding that we've got the polymer scientists, and understanding that I can take an application to them. I can provide all the information from a temperature, chemically resistance, mechanical resistance needed for this specification. If we're to 3D print this part, how do we need to build it out? What type of infill do we need? I want to make sure that what we print, we're able to put our best foot forward the first time. There's nothing worse than trying to introduce a new client into additive and having to do about 5 different iterations of the same part, right? So making sure that we've got all of our ducks in a row and pushing it out that way the first time.
Getting that first successful part off is probably one of the biggest challenges with open source equipment that we face with as well.
Well, and the thing is, it can come out and it looks perfect. You put it in the application and there's not enough infill, or you've got too much infill, right? So there is some pull and play there, but understanding the how it's going to be utilized in the system and making sure that you're not doing 5, 6 iterations, try to knock it out in 1 to 2 and prove the concept out. Now you've got an opportunity to not only be a service bureau, but potentially do proof of concept with that client to where now they want to bring in a Fortus 450 with these engineered materials and do it in-house.
Right on. It's really great to hear the technical strength that KIMYA has and the process that you go through to help enable some of these challenging applications. I would have not imagined specifically a kiln seal being solved with PEKK, and most people wouldn't think about a functional gear being made with FDM material. So can you talk a little bit about the missed opportunities that you see in our industry where that traditional mindset is such a hurdle that you just can't get past, and maybe some tips that we and our audience can be thinking about and able to, in order to help get over those hurdles?
Sure. Yeah. So should we take a look at the industrial sector in general? We're all going through a shift. You've got the generation, which is very close to retirement, getting ready to enjoy the next part of their life. And then there is an education gap between them and the new generation coming in who might be a little bit more tech savvy. So this mindset of utilizing additive as an alternative may not have been at the forefront of their minds and looking for alternatives to create a more efficient product or a more efficient part to help them produce. I think that we have a true opportunity here to work with the generation that's coming in and say, have you thought about this? Have you thought about what's out there as a healthy alternative to what you guys are currently using right now? Because in reality, you don't want to be stuck into that scenario in which production's down, parts broke, 6 months to get a part, I'm losing $100,000 a day. How do I limit my risk, limit my exposure, increase my overall sourcing options? And that could be with 3D, right? So it's asking those questions. Have you considered, have you thought about? Let's evaluate your systems and walk them down. I can show you what might be a viable option for FDM 3D printing. And then we can create a list, price point, and say, okay, now let's test these out and do proof of concept, right? I think that you'll have a more captive audience now in approaching it that way than we would have 10 years ago. So there's some true opportunity there. Like anything else in sales, you turn over every rock you possibly can to prove a concept out. And I think that opportunity is here for us.
Yeah, there's no doubt about that, and it's great to hear your perspective on that. You know, you're approaching it clearly as an educator, and an enabler, helping customers come to the realization of these unique solutions, and that's very much what we do as well. And we've got a lot of work ahead of us. There's a lot of educating to do, but there's tremendous opportunity where we can help customers bring their equipment online faster, have less downtime, and be less reliant on the laggard legacy supply chain. And in some cases, we're going to digitize it, and that's a really powerful tool for traditional manufacturing.
Yeah, absolutely. And what you had just mentioned there with digitizing, especially as it pertains to physical inventory, that's the other component, right? Limit that shelf space, put it on the digital, let us 3D print it, or you 3D print it. You save yourself a ton of money on just those annual rollover costs.
So where do you see the future going for KIMYA with these highly engineered materials, and where do you see that playing into the future of 3D printing, of additive manufacturing?
Yeah, so I know that it's important to continue to drive new initiatives forward. Frankly, understand what the market's yearning, right? You know, we obviously manufacture PEI and PEKK, but what does the market need? Because that's where we can really provide value with KIMYA Lab, and further developing more composite materials that might not be out there, or new applications that nobody was really looking at before from an additive standpoint, i.e. industrial, right? Is there specific applications that would require a specific material from a flame retardant standpoint, or whatever, whatever the specification might be? Let's continue to develop. Because if you're not developing newer materials that provide that value, you're going to let in the dust, frankly. Additive moves so fast. And that's something that I've had to adjust to over the last year, because I was used to something that was very consistent year in, year out, very project related. But this industry moves in hyperspeed, which is awesome. And it's going to continue to develop moving forward. And, frankly, as we continue to get buy-in from various industries, the growth is exponential.
It sure is. I couldn't agree more. So the good thing about today is that you've picked up a new customer, and we definitely have a need for highly engineered materials. Quality is extraordinarily important for us, and now that we've got access to the 450 and being able to run those new materials, the horizons really start to open up for us, and we have come across a ton of different projects that we didn't step into because of the complications of our open source equipment. And now with what we've seen so far with the 450, we're going to be stretching pretty hard into these new applications. So expect to get some phone calls from us. And with that,
forward to it.
And with that in mind, do you expect to be bringing more materials out for the Stratasys machine and for the Beta, for validated materials with Stratasys?
Yeah, so I sure hope so. I know that that's actually a conversation that they're having with our team in France. They're really driving the roadmap of the materials needed. But yeah, I mean, as we continue to go down this road together, I'm looking forward to getting additional materials on the 450 system, because at the end of the day, it's an extremely reliable system. The repeatability is there from a production series standpoint, and making sure you're able to tie your materials in with a system of that magnitude is absolutely huge.
Well, we're excited. We don't have our PEKK yet. We've got it ordered, and we're excited to get that in the machine and to start producing parts. And we'll share feedback, of course, with you and your team, as well as Stratasys. And we're looking forward. We're looking forward to that.
Fantastic.
Well, thanks so much for your time today. This has been a really insightful discussion. Hearing about KIMYA and where you're headed is, it's really helpful. It's energizing to see where the industry is going with leaders like KIMYA and Stratasys and DI Labs pushing the boundaries on solving problems with additive manufacturing. So thanks so much for that and for joining us today. This has been really great.
Hey guys, thank you so much for your time. I really do appreciate it.
Thank you. Have a great rest of the week.
All right, you as well. Take care.